Imagine handing a child 1,000 photos with no labels. They still sort them. Animals here, people there, landscapes in another pile. This is unsupervised learning. No teacher, no labels, just raw data, and the patterns hidden within it. In supervised learning, every example has a label: cat or dog, spam or not spam. The model learns from those correct answers, but labeling data is slow, expensive, and sometimes impossible. Think about medical records, sensor readings, or genetic sequences. Who labels all of that? Nobody. Around 80% of the world's data has no labels at all. Unsupervised learning is the answer. Give the model raw data and ask, what can you find on your own? The most intuitive form is clustering. These dots look like noise, but the data has hidden structure. When we reveal the natural groups, 3 clusters appear automatically: orange, cyan, green. No labels. The machine found them entirely on its own. The rule is simple. Points close together belong to the same cluster. Points far apart, different clusters. The machine measures similarity through distance. The most famous clustering algorithm is k-means. First, choose k, the number of clusters you expect. Step 1, place k-centroids randomly in the data space. Step 2, assign every point to its nearest centroid. The first pass looks messy. That's expected. Step 3, move each centroid to the mean of its assigned points. The flag moves to the true heart of its group. Repeat. Assign. Recompute. Watch the inertia drop with every iteration. When the centroids stop moving, the algorithm has converged. Real data is never two-dimensional. A medical scan has 50,000 features. An HD image, 2 million pixels. We cannot visualize that. This is the curse of dimensionality. Dimensionality reduction compresses that complexity down to 2 or 3 dimensions, preserving the core structure, discarding the noise. The classic technique is PCA, Principal Component Analysis. It finds the directions of maximum variance and projects all the data there. Thousands of dimensions collapse into 2. Clean, interpretable, ready. What if a neural network learns this compression entirely by itself? That's an autoencoder. The encoder squeezes the input into a tiny bottleneck, the latent code. The decoder then reconstructs the original from just that code. The network trains by minimizing reconstruction loss. No labels needed. Just how well did you rebuild what you saw? The bottleneck is forced to learn only what truly matters. Unsupervised learning powers the world quietly. Customer segmentation, fraud detection, recommendations, image compression, and genomics research. Raw data. No labels, pure structure. That's unsupervised learning. If this helped, like and subscribe to Vector Shield, and we'll see you in the next one.